Welcome to this session on sequences and series. Today, we will explore the fundamental patterns that govern numbers and how to calculate their properties. What is a sequence? A sequence is an ordered list of numbers arranged according to a specific rule. The general form is written as A1, A2, A3, up to AN. In this notation, A1 represents the first term, and AN represents the nth term. For example, look at the sequence 2, 4, 6, 8, 10, and so on. Here, each number follows a specific pattern of increasing by 2. What is a series? A series is the sum of the terms of a sequence. If we have a sequence A1, A2, A3, then the series is A1 plus A2 plus A3 plus all subsequent terms. For example, if we take the sequence 2, 4, 6, the corresponding series is 2 plus 4 plus 6, which equals 12. Types of sequences. There are several common types of sequences. Arithmetic sequence, AP. A sequence where the difference between consecutive terms is constant. Geometric sequence, GP. A sequence in which each term is obtained by multiplying the previous term by a constant ratio. 3. Harmonic sequence, HP. A sequence whose reciprocals form an arithmetic sequence. 4. Fibonacci sequence. A sequence in which each term is the sum of the two preceding terms. Arithmetic progression, AP. In an arithmetic progression, the constant difference is called the common difference, denoted as D. It is calculated as D equals A2 minus A1. In the example 3, 7, 11, 15, the common difference D is 4, because 7 minus 3 equals 4. Nth term of AP. To find any specific term in an AP, we use the formula AN equals A plus n minus 1 times D. Let's find the 10th term of the sequence 3, 7, 11, 15. Here, n equals 10, the first term A is 3, and the common difference D is 4. Plugging these in, A10 equals 3 plus 10 minus 1 times 4. This simplifies to 3 plus 9 times 4, which is 3 plus 36, giving us a final result of 39. Sum of n terms of AP. The formula for the sum of the first n terms is Sn equals n over 2 times 2a plus n minus 1 times d. For the sequence 2, 4, 6, 8, 10, let's find the sum of the first 5 terms. Here, n is 5, a is 2, and d is 2. S5 equals 5 over 2 times 2 plus 5 minus 1 times 2. This reduces to 2.5 times 4 plus 8, which is 2.5 times 12, resulting in a sum of 30. Geometric progression, GP. In a geometric progression, each term is multiplied by a common ratio, denoted as R. R equals A2 over A1. In the sequence 2, 6, 18, 54, the common ratio R is 3, because 6 divided by 2 equals 3. Nth term of GP. The formula for the nth term of a GP is AN equals A times R to the power of n minus 1. To find the fifth term of the sequence, 2, 6, 18, 54, where n is 5, A is 2, and R is 3. A5 equals 2 times 3 to the power of 4, or 2 times 81, which equals 162. Sum of n terms of GP. The sum of the first n terms of a GP is Sn equals A times R to the power of n minus 1 over R minus 1, provided R is not equal to 1. For the sequence 2, 6, 18, 54, the sum of the first 4 terms, where n is 4, A is 2, and R is 3, is S4 equals 2 times 3 to the power of 4 minus 1 over 3 minus 1. This simplifies to 2 times 81 minus 1 divided by 2, which equals 80. Infinite geometric series. If the absolute value of the ratio r is less than 1, the series converges.
The formula for the sum to infinity is S infinity equals A over 1 minus R. For example, in the series 1 plus 1/2 plus 1/4 plus 1/8, where A is 1 and R is 1/2, the sum is 1 divided by 1 minus 1/2, which equals 2. Harmonic progression, HP. A sequence is in harmonic progression if the reciprocals of its terms form an arithmetic progression. If 1 over A, 1 over B, and 1 over C are in AP, then A, B, and C are in HP. Example of harmonic progression. Consider the sequence 1, 1/2, 1/3, 1/4. If we take the reciprocals, we get 1, 2, 3, 4, which is an AP with a common difference of 1. Therefore, the original sequence is an HP. Nth term of HP. To find the nth term of an HP, we find the nth term of the corresponding AP and then take its reciprocal. The formula is AN equals 1 over A plus N minus 1 times D, where A and D are the first term and common difference of the reciprocal AP. Important property of HP. For 3 consecutive terms in HP, the middle term B is the harmonic mean, calculated as B equals 2AC over A plus C. Fibonacci sequence. In a Fibonacci sequence, each term is the sum of the 2 preceding terms. Fn equals Fn minus 1 plus Fn minus 2. The sequence begins 0, 1, 1, 2, 3, 5, 8, 13, and so on. Important table summary. To summarize, AP uses a constant addition rule. AN equals A plus N minus 1 times D. GP uses a constant multiplication rule. AN equals AR to the power of N minus 1. HP is based on the reciprocal of an AP. AN equals 1 over A plus N minus 1 times D. Thank you for watching. If you found this helpful, please subscribe and like the video for more educational content.